Captain Doug Brown. I teach in the engineering department. My primary duty is to teach midshipmen how to burn fossil fuels in huge amounts, 200 tons a day on big merchant ships. And that's my main job. My real passion and my sideline is to teach people about alternative energy so we can figure out someday how to avoid burning those fossil fuels and contributing to global warming and pollution of the environment and so on. What does it say? Can somebody back there tell me? Which solar hydrogen home? America's first. This may be the world's first solar hydrogen home. There's lots and lots and lots of solar homes around. They've been around for a long time. And all of those homes, including our home, ideally would get all of their energy to operate their home from sunlight. And on the roof of the house, we have about 40 of these solar panels. This technology school of architecture designed and built the main structure of the house. And our specialty, we've had a lot of experience working with solar hydrogen. We designed and built and installed all of the engineering systems on there, the plumbing, the electrical systems, the heating systems, everything else like that.
Come on, tell us, Shaft.
It's sturdy. It keep my back very straight.
Okay. So go cardboard?
Oh yeah, cardboard.
The key feature, besides the hydrogen system, is that all the engineering systems are inside this steel box. This is a 20-foot shipping container. It's a standard shipping container. There's hundreds of thousands of these all over the world. This is what they ship cargo in. This has got the bathroom, the kitchen. You probably noticed that. This is where we have our hot water system. What looks like a small refrigerator there is our fuel cell. That provides us our electricity at night. The tank next to it is our hot water tank. The way the pattern works, the electricity comes down behind this wide board, this column right here. So that's where all the electricity from our solar panels comes in through that, goes up into these three boxes. Now, that photo panels make DC electricity, direct current electricity. And in the house, most of the electricity we use, or a lot of the electricity we use, is alternating current. So anytime you see solar panels on a house, one of the things that goes with the solar panels are these things like you see in these two white boxes right there. Those are inverters.
Yeah. Isn't using hydrogen dangerous because it's flammable?
Hydrogen is flammable. There's lots of flammable gases. Hydrogen is one of the least dangerous flammable gases you can imagine.
How long does it take for this house to pay for itself?
This house will never pay for itself. The price of oil would have to go up to $1 million an ounce, I think. Because it actually is if we had a conventional battery system that would pay for itself, that system would pay for itself in 4 or 5 years, maybe even immediately, because of the value that it adds to the house. This rack of glass tubes up there is where we get the heat for our hot water. You could take one of these tubes out of the box, which I've done, and aim it at the sun. And at the top of the tube, you can see where the tube terminates. They have that long rectangular box. Well, inside that long rectangular box, every tube has a copper bulb about as thick as your thumb at the top of the tube. And what happens is the sunlight, like even on a cloudy day right now, this radiant heat from the sun is making its way through the clouds, through the glass, into the fins inside those tubes. And since it's a vacuum inside the tubes don't know what the air temperature is outside. It could be 20 below zero, and the fin on the inside of that tube would be getting the radiant heat from the sun, but it wouldn't be losing any heat really to the surrounding environment. And the bulb at the top would get as hot as 300 degrees Fahrenheit. So at the top of each one of those bulbs, I'd say right now, with the sun the way it is right now, the temperatures of those bulbs are about 150, 160 degrees Fahrenheit. Unsupported flagpole.
Unguided flagpole.
Unguided, yeah. East of the Mississippi. There's only a couple in the world like this. So when they put it in, there's a 10-foot by 10-foot cement box underneath it that this flagpole is mounted in. And halfway up, when they put it together, they welded the upper half to the lower half in place, so that somehow they were able to put that upper piece up there and weld it. Anyway, I don't know how they did that. So it's 172 feet. All the bulbs have been taken out for the winter, but the King's Pointer is our training ship. So on weekends and sometimes on the evenings, cadets go out and they learn how to operate the engines, and it's mostly for training the navigators how to navigate. So all the midshipmen do. They take 3 months during their sophomore year and about 5 or 6 months during their junior year, and they go out, usually 2 to a ship, 2 to 3 to a ship. They pick their sea partner, a best friend to travel with, and they'll go out and they'll work on these big ships. I mean, they're really big ships, huge ships, and travel all over the world. All these big ships have machine shops in them where they can take raw metal and make spare parts for the engines or repair broken things, welding shops and so on, because when you're in a ship at sea, you can't make a run down to Home Depot to buy nuts and bolts that you might need to fix something. So they're all able to make that. So every freshman gets some time in the lab. The engineers actually get quite a bit of time in here. It's what we call our diesel lab. These are the kinds of engines that we use on ships to provide electricity. This will be hooked up to electrical generators, and they'll provide electricity for a ship. An engine has 16 or 12 cylinders, but the way the diesel engines work, you have a piston that goes up and down inside a cylinder, create an explosion, pushes the piston down, and then you have a crankshaft that works like bicycle pedals. Well, if you can picture 12 bicycle pedals put side by side, each one with its own hooked up together, that's what one of these full size engines would look like. So you take this piston and you put another one just like it right up against it, another one, and have 12 cylinders. You can picture how long that engine would be. Now picture an engine that's almost twice as high as this one. That's 12 cylinders long, and that's what's on these big ships now.
Guys, if you want to take a look at the top of that engine that you guys are just looking at, this is the cylinder head for one of those gigantic piston cylinders, one of the cylinders for the diesel engine that Captain Brown was talking about earlier.
The altar up here, this is set up right now for the Catholic services, and it rotates, it's three-sided, and it'll rotate around, and it'll have the Protestant crucifix, and it'll rotate around further for Jewish services. So they have all 3 services here each week.
Now, ladies and gentlemen, you're looking at the captain, Captain Brown. Let's give him a thank you. 1, 2, 3. Hip, hip. Hooray! Hip, hip. Hooray! Hooray! He is standing down there with a Action Jackson in his hand. For the world's fastest man.
Thanks so much for coming to visit Kings Point Merchant Marine Academy. Thanks for your interest in our alternative power program and our solar hydrogen house. And we hope to do this a lot. So we'll hope to see you again in next year, if not sooner, for another trip. That'd be great. Thank you very much.